Good morning and happy September. My name is Joel Tickner. I'm the Executive Director of the Green Chemistry and Commerce Council, and I'd like to welcome you to today's GC3 webinar entitled The Invisible Wave, Getting to Zero Chemical Pollution in the Ocean. So today's presenter, let me give you an introduction to today's webinar. My introduction to ocean chemical pollution was very early in my career when I read a Greenpeace report entitled, that was written by Professor Donald Heising, entitled Pollution of the North Sea, Time for Clean Production. The report spoke about the impacts of persistent and bioaccumulative pollution on the ecosystems of the North Sea and the need for precautionary action, employing pollution prevention, chemical substitution, and cleaner production to address that contamination. Nearly 30 years later, Economist Impact Group's Back to Blue initiative report has really brought together the science, the continuing science, and the similar problems, showing the concern over marine pollution at a global level. In the report, Marine Chemical Pollution, the Invisible Wave, highlights, we've had this growing concern over ocean plastics, but there's this invisible wave of ocean toxics that we have not adequately addressed. And this report really highlights both the challenges, but then the opportunities of really rethinking chemistry so that we can maintain and enhance ocean biodiversity and integrity while leading towards safer, more sustainable chemicals and materials. We have two amazing presenters for today's webinar. We have Charles Goddard as Editorial Director of The Economist. Charles Goddard imagines and builds the Economist Impact Group's flagship initiatives, the purpose of which is to catalyze progress on key issues of the day. He works closely with partners on themes ranging from aging and longevity to ocean health, focusing particularly on healthcare, the Anthropocene, and the blue economy. Based in Hong Kong, Charles was previously Editorial Director of Asia at the Economist Intelligence Unit, Director of Research in Asia, and Managing Director of the Economist Corporate Network, a peer network for senior executives. He is currently Executive Director of the group's World Ocean Initiative. And as you'll hear today, Charles has the most amazing voice, and he should be a radio and TV personality as well. And then we're also very honored to have Dr. Elsie Sunderland, who is the Gordon McKay Professor of Environmental Chemistry and Professor of Earth and Planetary Sciences at the Harvard John A. Paulson School of Engineering and Applied Sciences. She holds faculty appointments in the Harvard John A. Paulson School of Engineering and Applied Sciences, the Harvard T.H. Chan School of Public Health, and the Department of Earth and Planetary Sciences. A main innovation of her group's work is to quantitatively analyze the entire exposure pathway for aquatic pollutions to identify key processes that have a large influence on their accumulation in biota. And prior to joining the faculty at Harvard, she spent 5 years working to inform environmental policy decisions at the U.S. Environmental Protection Agency in various offices. She's worked extensively on PFAS and mercury contamination, and her work has achieved international recognition and has been integrated into major international policy efforts. And I had the honor of teaching one of her classes in the School of Engineering at Harvard, and found just the inspiration of training a new generation of engineers to think very differently about their field. So I want to thank both Charles and Elsie for joining us today, and pass to Charles. Thank you so much, Charles.
Thank you, Joel, very much indeed. And thank you for your very kind comments, even about my voice, which I'm not entirely sure is true, but I'll try my best to give you the dulcet tones from here in Asia. Really, I'm very delighted to join you today, and most grateful really for the opportunity to talk to GC3 and its members about the invisible wave, getting to zero chemical pollution in the ocean, the report that we launched earlier this year. And Joel, let me convey my thanks to you also for your participation in the report, and to Elsie Sunderland, who'll speak after me, for your participation as well, and for your sound and sage thoughts and advice. It really, really was enormously helpful. Thank you. Let me just step back very briefly for a moment. I mean, I wouldn't be surprised if you're familiar with The Economist to find it odd, for you to find it odd, should I say, that the Economist Group has been active on ocean sustainability issues now for more than a decade. And that's principally through our World Ocean Summit. And when we started that summit in 2012, the discussion around ocean pollution was really in its quite early stages. I mean, at least in its present form. And there has, of course, been a long discussion, as Joel mentioned. 30 years ago, he was reading about this, but there has been a long discussion about ocean pollution. But really, the way that it's been galvanized in the last decade has begun, I think, to change the way in which this discussion is now evolving. And I think even back in 2012, it was quite clear that human activities on land in particular, but also human activities in the ocean, were causing really a significant and perhaps unprecedented decline in the health of the ocean. And we understand those impacts now as climate change impacts, so ocean acidification and warming, the loss of biodiversity, mainly from things like overfishing and indiscriminate fishing or illegal fishing. And pollution, of course, and most of that is a focus around plastics. And as we now begin to understand it better, chemicals, I hope. And of course, those stressors, those anthropogenic stressors, are exacerbated by a growing industrialization of the ocean. And of course, we've all long thought, and I'm sure I'm part of that process, that we've all long thought that the ocean, the largest single ecosystem on the planet and responsible for 50% of our oxygen in the atmosphere, was really impervious, pretty much impervious to pretty much anything that we wanted to throw at it and anything we wanted to dump in it. But of course, we now know that that is not, of course, true. And in fact, if you look at what the IPCC says, even on the climate, the Intergovernmental Panel on Climate Change, even on the climate, we are now undermining the ocean in ways which are undoubtedly threatening, I think, the wider stability of Earth systems. And anyway, we look at one of those anthropogenic challenges, pollution, in this, and one of our key things in this Back to Blue program, which is a program that we're working with the Nippon Foundation on. Nippon Foundation is one of Japan's largest foundations to look at sort of broad health issues in the ocean. This particular mission, at least in its early stages, is to shape and support progress towards zero pollution in the ocean. And I say all this really as by way of background for our brief discussion today on chemical pollution in the ocean. And of course, one key challenge of chemical pollution is that marine chemical pollution is largely invisible, quite literally, and also quite metaphorically too, in the sense that it really barely registers as an issue in the wider ocean discussion. Or indeed even for businesses, I think, and the wider general public. And it's not really on the radar, for example, of chemical companies, which it should be, but it isn't. And they certainly, I think, in most cases, don't consider how chemicals impact the ocean. So really the primary aim of our report, The Invisible Wave, is really to make a start, a new start, a fresh start in a way, and it's by no means exhaustive, to bring chemical pollution to, and the gravity of this problem, what we consider to be the gravity of this problem, in front of a wider audience, in front of policymakers, governments, the chemicals industry itself, of course, and the broader business community and finance and civil society, and indeed, to some degree, the general public. We also wanted to sort of broaden the narrative on ocean pollution. And if we look at it, the discussion around plastics has taken pretty much a decade or more to galvanize itself, to come to fruition in a sense. And we are going to be looking soon at a potential UN plastics treaty. And of course, plastics was helped by the visibility of the problem, and a problem we can all recognize because we all see it. But our question to ourselves is what really would it take to get marine chemical pollution into the public consciousness and onto the national and the global public policy agendas? And And that's not an easy problem, as we found to solve, as we found when we went to the United Nations Ocean Conference in June in Lisbon, where primarily the discussion was around plastics. And there was really a big gap in perceptions about the importance of, or the gravity of, the urgency of, should I say, chemicals and other pollution in the ocean, with many scientists, of course, thinking that this was a really critical problem, but many others in the business and other communities either not aware of it or barely beginning to consider it, with their hands full with plastics and various other things. So what did our research tell us about the problem itself? Well, let me begin by just sort of identifying briefly what we took to be chemical pollution and its sources. And most of that pollution begins on land. I mean, there's a guesstimate, an 80-20 guesstimate, as you might imagine, but there are no real figures around this, with the rest generated at sea from sources such as extractive industries and shipping and fishing. The land-based sources of synthetic chemicals and pollution come in numerous forms, and we've thrown a very wide umbrella around this. So from nutrient pollution, from fertilizers mainly, but also sewage and sewage of humans and animals, heavy metals, so mercury and cadmium, for example, persistent organic pollutants, including PFAS, or forever chemicals, pesticides, pharmaceuticals waste, radioactive waste, plastics and microplastics and nanoplastics, and the chemicals that are in those, and chemicals that really are in the vast majority of household, consumer, and industrial products and processes. Indeed, chemicals that, fundamentally chemicals without which modern society doesn't really operate. And those chemicals go into the ocean mainly through freshwater systems, through rivers, lakes, and watersheds, as well as from runoff from roads and from cities, and through atmospheric deposition. So, much of the chemicals, for example, found in the high seas or indeed at the poles comes from atmospheric deposition. So how extensive is it? And what do we know about its impact? Well, with very few exceptions, I think, and perhaps dead zones, and I'll come on to that in a second as one, we found these questions quite difficult to put clear numbers on. In good part, I think that's the science and the evidence base. It's all been conducted in a relatively atomized way, without a particular broad strategic intent. So we don't have a lot of joined up dots in the science and the data. But of course, there is quite a lot of science out there around this question. It just needs to be put together despite the fragmentation. But there are also clearly very substantial gaps in the knowledge and the evidence. So I think we can say with confidence, though, looking broadly at the science and the evidence, that a wide variety of synthetic chemicals are present right across the ocean. From coastal and estuarine environments, from top to bottom in the ocean, right into the very deepest parts of the ocean, as well as also in all kinds of marine life, from corals to cetaceans, dolphins and whales, and fish, and even in the smallest microorganisms. And rather like plastics, I think, as we're beginning to understand the scale and scope of that problem, we are beginning to understand too that the ocean, pretty much everywhere in the ocean, there are traces of some sort of chemicals. And perhaps that shouldn't surprise us in some ways. What impacts are we seeing? Well, it's difficult. Again, the impacts are quite difficult to quantify and to qualify. But we can mention a few just by way of example. Growing nutrient pollution is resulting in dead zones where there's deoxygenation, a lack of oxygen, and the fish life, the aquatic life dies. Say, for example, the evidence of sunscreens and their impact on corals, and chemicals such as oxybenzone and its impacts. The nanoparticles in oxybenzone, which carry chemicals too, interfere with the growth cycle of corals and their ability to reproduce. Forever chemicals, PFAS, have been found also in the deepest ocean, but also most recently, just last week, I saw an article on PFAS in crayfish in Sweden, exceeding the present recommended, way exceeding the present recommended limits. And of course, we know that, it to be true that fish at the top of the food chain, fish such as tuna, are harboring lots of toxic chemicals, as well as particularly heavy metals, and that these have an impact on reproductive and growth cycles too. And there are plenty of examples too of seas and specific ecosystems, ocean ecosystems, which are in a really serious state and state of near death in some respects, as a result of a combination of human-induced factors, including chemical pollution, playing a particularly significant part. And so we can name, say, for example, the Bohai Sea in China, the Baltic Sea in Scandinavia, and of course, we all know of the case of Minamata in the Shinonoi Sea in Japan, if nothing else, through Johnny Depp's most recent film around that. And there are some examples of bays that have been cleaned up of major chemicals. Monterey Bay in California, I think, is a very, very good example of that, where there's been a long cannery industry had really fundamentally disrupted the environment in that bay, and this is now being cleaned up. And the report cites many other examples of these kinds of things, but new evidence too, really, that's emerging of almost weekly. I think that concentrations of toxic chemicals, many toxic chemicals in the marine environment continue to rise. And I think it's worth just reiterating, even though this is a GC3 audience, and I'm sure you're completely aware of this, it's reiterating that there are tens of thousands of synthetic chemicals in use, with thousands being added each year. Yet in most cases, and particularly in the ocean environment, most cases, we have very little understanding, if any, about the impact on the ocean or on ocean life. And that many of those chemicals are rarely tested in any significant way for their impact on ocean life. And as we produce more chemicals in ever greater volumes, so the impact on the marine environment and marine life is likely to increase. I think one clear conclusion, and just to wrap this part up, one clear conclusion is that much more research is needed in order to be able to determine that impact and determine the scope and scale that chemicals inflict on the environment. And I think it's really striking. One of the striking things is that there hasn't really been any serious scientific assessment at scale of marine chemical pollution and its impact on marine biodiversity and marine ecosystems. And that's something that we are looking to sort of help address. Change slides, please. Very briefly, so what does it cost us? Well, not surprisingly, there has been no attempt to quantify this either. So we made a brief stab at it. We modeled the cost of inaction on the US fishing industry in the Gulf of Mexico of worsening dead zones. And dead zones are caused by nutrient pollution or excessive nutrient runoff from nitrogen-based agriculture and sometimes human and animal sewage. And it usually sort of flows down rivers into estuaries and into coastal areas, resulting in deoxygenation, as I mentioned before, and the dying off of aquatic life. And the number of those zones is rapidly increasing across the world. And we found, very briefly, that if dead zones worsened in the Gulf of Mexico, it could cost $838 million annually in lost revenues in the Gulf of Mexico alone. And of course, if you extrapolate that forward by way of illustration there, you extrapolate that across the world to what the impact of dead zones alone might be from an economic point of view, it is very significant. Then the question is, what would the overall impact economically of chemical pollution be? And that's, of course, a much more difficult question, but nevertheless, you can gain a sense of the scale of that problem. Next slide, please. So let me turn now briefly to what might be done. And I think the very first point that I would make is that despite the fact that we don't have a complete and full picture of what, the scope and extent of marine chemical pollution, I think failing to act now is really a risk too far. We really have to move and take urgent action. The second, I think, thing the report says is that marine chemical pollution is fundamentally a global problem. The ocean is a global ecosystem. It's a global problem. It is everywhere. And the only way to address that really is in a systemic and coordinated way, with a systemic and coordinated response at national, regional, and indeed global levels. And that response, in a piecemeal way, that response is beginning to evolve, and the response to chemical pollution more widely is beginning to evolve. And of course, marine chemical pollution is really a subset of that broader chemical pollution question. But that's slowly getting underway nationally and regionally, but bringing marine chemical pollution into that wider discussion and recognizing its own idiosyncrasies, because there are plenty of them, is going to be essential. At the moment, marine chemical pollution is largely absent from that agenda. Next slide, please. I think the first thing that I would mention in the solutions question is really regulation and the role of regulation, particularly in a world where chemical production has been undergoing massive geographical shift from Europe and America to Asia, to China, and to the Middle East. And as production, of course, is forecast to rise significantly to meet growing demand. I think the first point I would say here is that the quality and the effectiveness of the current legal and regulatory landscape is highly variable from country to country and generally quite underwhelming in most of those countries. In the international environment, it is also complex, but also, I think, ultimately largely ineffective. So it's not really fit for purpose at this time. And of course, there are many laws and treaties and regulations on chemical and, to some degree, lesser degree, but nevertheless, they're marine chemical pollution at the national, the supranational, and the regional level. Europe's REACH legislation, which I'm sure you're aware of, for instance, is among the more proactive and the most proactive of those, puts the burden of proof on companies to show that their products are not harmful. Many countries' legislations tend to be more reactive rather than proactive, and I think it's quite true that the pace of innovation in chemicals is so much faster than the pace of innovation around regulation. Regulation is, thousands of chemicals coming onto the market every year, and now regulation is a long way behind the ability to manage harmful substances and chemicals that are coming into the market and manage them properly. I think given that there is a shift in a geographical shift happening, the focal point of future innovation in chemicals, which is Asia mainly and the Middle East, is not the focal point at the present time of regulatory innovation. So that's a big challenge, and that raises a number of particular issues. And of course, it is clear that regulation will have a key role in mitigating marine chemical pollution, but putting well-designed regulation in place is not in and of itself a panacea, and it's not in and of itself going to solve the problem. It needs to be enforced, for one, and it certainly needs, in places like Asia, where the shift in production is moving, it certainly needs to be addressed in those places, because quite obviously in those places oversight is far more limited. We listed, and I'm not going to go through all of them, but we listed a number of interventions that might help, from a regulatory point of view, combat marine or address marine chemical pollution. And I'll just mention a couple of them here. One of them is a global treaty on chemical pollution and a subset, marine chemical pollution. And we now have a global treaty being negotiated on plastic. So I think there is room for potential perspective for one on marine chemical pollution. The precautionary principle, that needs to be put in place. And of course, REACH does that, but that's the exception, not the rule. A global science policy body to bring science to policymakers, I think, is extremely important. And indeed, that was agreed at the UNEA meeting in March earlier this year, at least the start of such a body. And of course, things like a comprehensive register of chemicals, as well as mandating disclosure of chemicals in all products. And these are just a few of the kind of regulatory issues that might work and might sit there. Change slides, please. I'm almost near the end here. And I think, you know, the regulation is important, is hugely important, and it will be a driving force, particularly in certain areas where, you know, Europe, for example, is a regulatory superstate in many ways, and so with high levels of compliance, and so that's going to be a particularly important driver there. But I think in many other respects, the role of the chemicals industry itself and you know, companies further along the value chain, particularly, will be more important still in the transition to a less hazardous world. And I think it's probably the most compelling opportunity, really, in resolving marine chemical pollution. And what is compelling about it? Well, in particular, I think green chemistry and the circular economy really are the keys to that change. But I think despite the opportunities that are there for green chemistry and for more sustainable chemistry, the change for the chemicals industry is likely to be quite complex. It's likely to be costly. It's likely to be painful because it's enormous, you know, it's an industry that's enormously reliant on fossil fuels. It's very, it's sprawling, it's diverse. It has long and complex supply chains, and of course it's very capital intensive, and it has relatively low margins. And so I think that incumbency or that inertia in the chemical sector is quite a problem. And indeed, you know, the report does look at that question of, if the industry doesn't begin facing up to some of the looming problems that it has, in particular climate-related sort of regulatory issues and financial pressures, it could face an existential crisis. Or otherwise, it might risk having change foisted upon it by regulators, or by, to some degree, indirectly by consumers who sort of increasingly are aware of and beginning to pressure consumer goods companies, particularly, to make changes in this area. And I think it's fair to say that at the moment, efforts from the industry have been weak, to say the least, and piecemeal, and that really, fundamentally, a real progress will need a shift in thinking within the industry, a cultural shift in the industry, and indeed a systems level change. And I think perhaps the most exciting part of that change potentially is, you know, what's really sort of almost inherent in the industry itself, and that is innovation, scientific innovation, and green chemistry particularly, which offers the opportunity to design sort of high performance products that are less toxic and less harmful. And many of those technologies already exist. And there is, of course, a very vibrant startup scene. And that transition, you know, that is already beginning. The green chemistry share of the market is beginning to grow. It's growing quite fast. It's the fastest growing part of the market, even though sort of from a very, very low base. And the number of patents, of course, and other indicators still are very broadly low. So innovation, creating commercial incentives to change. There has to be a profit motive for commercial companies to want to make these changes, and perhaps a coalition of the willing across to help first mover disadvantage, to get over that first mover disadvantage of the investments that are needed and the risks that need to be taken, that help bring industry players together to collaborate a little bit more around those things, increasing transparency and collaboration across the supply chain and working with companies and others further down the supply chain. These are some of the kinds of solutions that I think would be brought to bear in the context of the green chemical revolution that is needed if we are going to fundamentally address some of these chemical problems, both on land and of course in the ocean. And of course, finance, lastly, has a real role to play in the transition, as it does with climate change and wider sustainability issues. And you'd be looking for, improved ESG guidance and regulatory standards, as well as much better data to allow ESG-related investment decisions to really take shape, and for us to understand which companies and others are not, in a sense, are harming the ocean through harmful chemicals, and how to address that from an investment point of view, making decisions about which investments, particularly asset management companies and others, and other investors would want to make. So I'll stop there, but urgent problem. The science is telling us that, and it's really high time that we begin to address this. It receives far less attention than plastics. It shouldn't do. Plastics is very important, and there are lots of connections between chemicals and plastics. But chemicals are equally important too, and we do need to begin an urgent, coordinated task if we are going to prevent irreparable harm to the ocean, and that will require a systems-level change. Thank you.
Great, thank you so much, Charles. Great overview of both the magnitude of the problem, but also the opportunities we face. And now Elsie Sunderland will talk a little bit about more of the data on the problem, which has been her background, but definitely working with engineers. Those are the people who can solve what we've created. So Elsie, thank you so much for being here.
Okay, thank you so much, Joel, for the invitation to talk to everyone today. And thanks, Charles, for that wonderful introduction to the issue, and also for pulling this report together and a number of videos. The links are in the presentation, so I encourage anyone who's listening to check out the report and check out those videos. I'd like to just spend a couple minutes before we move to open discussion thinking about the nature and scope of the problem and how that frames our approach to solutions. And I'd like to just start with this reflection that human activities are transforming the global environment, which Charles already alluded to. And when one makes a statement like that in today's world, typically we think about global climate change. And I'd like you to think just a little bit beyond that in the context of the discussion we're having today about these two issues as highly interlinked issues. So when we burn a carbon-intensive fuel source like coal, we release more than 200 different hazardous air pollutants, including things like lead, arsenic, and mercury. At the same time, they're transported in the atmosphere and truly deposited globally in the environment. And so we find them in the most remote corners of the earth, as Charles also mentioned. The other linkage is really through our sort of modern economic system. So those same fossil fuel feedstocks that we're using for energy sources right now actually provide, and Joel is much more knowledgeable on this topic, so perhaps we can chat about this a little bit, but they're providing a cheap source of the parent chemicals to those thousands of synthetic, organic, human-made compounds that we're releasing to the global environment. And so these issues are intricately linked. And as we're thinking about addressing climate change, so we're thinking about our global chemical experiment with our climate system, then those same companies are actually thinking about where to divert that product. And what they're thinking about is diverting it into both plastics and synthetic organic chemical production. So as we think about addressing climate change and the ecosystem changes that we're seeing, we have to also think about this global chemical exposure problem. And so I call this the global chemical experiment with our health. It's the parallel experiment. And the reason I call it that is because we really do see alarming public health statistics at this time. So when we're talking about a marine environment, we're talking about exposures through seafood, which is one of the world's last wild foods that we harvest from the environment. It's truly a globally, so in the commercial seafood market, this is truly a globally distributed food. When we look at the public health statistics, we see alarming statistics like 1 in 6 children suffer from a neurodevelopmental abnormality, mostly of unknown causes. When we look at trends in the epidemiological data over time that are corrected for factors that we might expect to affect disease, so we correct for various changes in lifestyle and diet over time, then we do see alarming rises in a number of chronic diseases related to immune function, cardiovascular health, neurodevelopment. And those are all endpoints that have been linked to many persistent organic pollutants and heavy metals that we're releasing to the environment. And they're now, again, as Charles mentioned, ubiquitously present in even the most remote corners of the earth. So this is the global chemical experiment with our health that we're facing. There's not a ton of awareness about what's happening right now. So I just want to speak to this for a couple minutes. So if we can advance to the next slide. So again, thinking about the interlinkages of these issues, when we're talking about the marine environment, we're really talking about chemicals. So when we're thinking selfishly about our own health, from a public health perspective, then we're thinking about being most concerned about those chemicals that biomagnify in food webs. So they're concentrated. So you might have low levels in the marine environment, but they're concentrated to very high levels, 1 million times or more in higher trophic level organisms. So some of the fish that we really enjoy eating, like tuna. And one of the things that we're finding for certain classes of compounds, so these are things like mercury, where we've actually been very effective at regulating them, that the environment is actually a major vector of exposure. So here I'm showing you an example from one of our studies. It's on Atlantic bluefin tuna in the Gulf of Maine, showing that seawater warming alone led to a dramatic increase in the concentrations of mercury in these Atlantic bluefin, commercially important Atlantic bluefin tuna. So this reflects changes in the metabolism of the fish, but more broadly reflects how that as we change the backdrop of these different ecosystems, that's changing the vector of exposure for many of these toxic ocean pollutants. Next slide, please. Another class of compounds, so again, illustrating this same trend, are some of the what we call legacy persistent organic pollutants, so things like PCBs, which were banned in the around 1970, but we still see them sort of ubiquitously in the global environment. Now, we've seen improvements, concentrations have gone down, but we see in remote ecosystems like the Arctic, where things like sea ice melt are exacerbating concentrations of these compounds in surface waters and then changing biological exposures as a result. And next slide. And so I want to sort of go back to the point that, okay, so we need to acknowledge, as Charles said, that this global chemical pollution is a large public health concern. I would argue that it's a much larger public health concern than microplastics. When we release these compounds at low levels in the environment, it impacts everybody's health, and we need to start thinking about ways to address this. And there are different magnitudes of problems in different areas. And I'm often accused, as I show you slides like I just did, of being depressing, and that's not the message I want to convey today. So in this slide, I want to show you that when we think about this systemic and coordinated response, to this issue, having that response is actually incredibly effective. So we're talking about in the media, in our, in the news a lot, these PFAS chemicals. So these are what people call forever chemicals. And I want to show you this example just to show you how effective we can be if we take that global action. So this is an example for a compound so PFAS, one of the most prevalently produced compounds around the year 2000. If you look on the far left, you can see the ramp up in chemical production in the North Atlantic Ocean. So here it is accumulating around peak production. And industry voluntarily phased it out. The major global producer voluntarily phased it out at that time. And it was added to the Stockholm Convention on Persistent Organic Pollutants shortly after. And what we see in seawater, marine mammals, and human exposures shortly thereafter are these rapid declines in responses of the ecosystems. And I use this as a case study to show you that through that coordinated and systemic response, we can actually fix this problem. If you go to the next slide. And so we need to, in summary, I think about the intertwined nature of this chemical pollution issue, both globally and in the marine environment, with issues related to climate change, particularly when we're thinking about public health outcomes and what it means for different human populations. And as we try to shift towards solutions, I think we really need to revisit this idea of, what does our modern, these chemicals are a component of many, many aspects of our modern society and consumer products, and where are they essential? And in many, many uses, they're just not essential. And in many cases, we don't even know they're there. So increasing that transparency around this issue, defining essential uses, choosing safer alternatives, both from a regulatory perspective, but I would argue also consumers and individuals and NGOs and reporters, like talking about this issue, putting out this information will have a big impact. And we've seen this again through case study work on the PFAS chemicals and in relatively rapid responses to some of the concerns around these chemicals. And my final point would just be that, if we want, if we do take action and we can find a way to have that coordinated action, we typically see rapid responses in the environment, benefiting the ecosystems themselves and also benefiting us. So rapid reductions in human exposures. And so with that, I'd love to hear other perspectives. I don't know, Joel, if you wanted to say a few words to wrap us up and kick us off.
Thank you so much. And Charles, if you can come back on, I think I really appreciate, Elsie, the positive ending here, right? Like, it doesn't have to be this way. And I think the Invisible Wave report does the same, right? We've got to have a problem to have a solution, but the solutions aren't out of reach. They're just complicated in some ways, but in some ways they're easy, right? You as you showed in that last graph, you phase out the chemicals and the levels go down. I mean, we have a beautiful public health story when we phased out lead in gasoline, right? Our blood lead levels dropped precipitously in a small number of years, and we alleviated a public health crisis. I mean, still there in some ways, but we significantly reduced that crisis. So I would ask anyone who wants to ask a question to please put your question in the chat, or you can use the raise hand button, which is under reactions, if you wanted to come on and ask that question live. I'll start with a question to the two of you. Charles, you sort of spoke about the idea of a coalition of the willing, and what does that coalition look like? Who is in that coalition? Who needs to be at the table to start addressing this problem at the scale that we're going to need to address it, given some of the that now
a set of solutions that are that are adopted by, or at least in adopters of green chemistry or sustainable chemistry, progressive companies, of which there are a number, mainly at the moment in the European Union, in Europe, but there are, of course, examples in the US, and there are plenty of smaller companies that are also looking specifically at creating sustainable chemistry in order to be able to, create opportunities for themselves. It's really that group that we were hoping to initially draw together as part of the coalition of the willing, or we suggesting should be drawn together. And it was one of our thoughts that perhaps we might do that, look going forward. Not an easy thing to do, because of course, I think when you start to get into, there's quite a bit of resistance, should I say, in companies to sort of engage in these processes and engage in discussions and dialogue around the transition that's needed, the complex transition that we were talking about earlier that's needed. So that coalition of the willing, I think, is the group of potentially progressive companies that could help start a process of discussion around marine chemical pollutions, and already is beginning and is in evidence in GC3, I think. It's that group, and extending the marine chemical pollution discussion out of the discussion you're having, I think is one way of potentially looking at that.
Great. And you've highlighted in a recent blog one of our GC3 members, Solugen, and some of the uniqueness of their chemistry, and which is a solution to both the petrochemical question and the toxicity question. So you can solve both with one solution. Now, what do you think, Elsie, about this question of, who is the, where do academics fit into this question? I mean, you're speaking out not as a typical academic, but where do us as the academic community fit into, driving solutions to this problem?
Yeah, so I think that's a great question. So I think it's not all academics will share the opinion that I have, but I think it's our responsibility to make those causal relationships clear, so that the drivers and then the extent of these problems and then the potential benefits from some of these actions. And we can really do that. And I think, we all bear a responsibility to not only do that, but then take them to people like Charles, who can articulate them so much more eloquently and with a kind accent. That makes it sound better, and get it out to the world, because academics are not known for their ability for public outreach. I really think working with doing this, we need good science, we need these numbers, we need the data. I think Charles alluded to this as well. We need this global scale, large scale synthesis, and not these fragmented pieces of research on this specific issue, right? A lot of academic work is done in kind of corners, and then the generality or the implications globally with the same jurisdictions used for the regulatory structures aren't there, and so that makes it very difficult. But I think that it's that interface between academics and the world that's so difficult. And Joel, you're not a typical academic either, in that you're doing that in your everyday life and have for decades. And GC3 is a wonderful example of what an academically based group can do in terms of impacts and innovation. So I think we need just more of this, and we need to listen also to what kinds of, so Charles was outlining, and also the Invisible Wave report outlines sort of a clear set of, hey, we have big gaps here. We want to be able to say, these kinds of things, but we don't quite know yet. So that's our job.
Good. Let me follow up. There was a comment in the chat about enforcement in the Middle East, and you and I, Charles, have been talking about this, and the report alludes to, and you spoke about this today, is the largest areas of growth of the petrochemical industry are, Asia and the Middle East, and where there may not be the recognition of these challenges the same way. How do we sort of evaluate that or address that challenge of this is really a global issue and not necessarily a US or a European issue where there's more, well, at least Europe, the increasing regulation in the US and Europe with the Green Deal.
And I think you're absolutely right in saying that there is a huge gap in our understanding of both the sort of scale and extent of chemicals production in Asia, in the Middle East, in China. I mean, part of that's a language issue, and part of it's just a sort of the fact that we haven't really been looking at that question in great detail, and the industry is looking at that question, but perhaps the wider stakeholders who need to be involved in the discussion around chemicals haven't been looking at that question. We are, in fact, over the course of the next 6 months, producing 2 or 3 pieces that look at chemical production and the state of chemical production and pollution in China and also in the Middle East, just to sort of pick up a gap that we had in our own report, because there wasn't really a great deal of information around it and not really a great deal of transparency, not necessarily deliberate, but nevertheless, it just simply wasn't easily available. So we're trying to fill that gap a little bit. And one of those gaps too is this question of what, from a regulatory point of view, is missing in places where, oversight is generally quite limited, I think, and the need for greater levels of oversight, and the need to manage things, for example, like regulatory arbitrage, where companies move from Europe or America into places where there is less oversight for chemicals, and put their operations there where the regulations are less onerous, and what can be done about that, and whether regulations and enforcement in those places, and somebody mentioned in the chat box for the critical need for greater enforcement can be strengthened. So I think there is more work that needs to be done, and we're particularly interested in trying to uncover some of that in order to be able to make it clearer, and also to put a greater, as you say, Joel, a more global sort of perspective on what is, after all, a global industry with global production and global pollution.
Mm-hmm. Great. Yeah, there's a question in the chat for both of you that is interesting. Yeah, the New York Times recently reported on the mining of deep sea riches, nodules containing valuable metals, and the potential environmental harms of doing so. And just the question about, are we just shifting to a new set of problems? Do we know anything about this and the potential impacts? I don't know if you want to start, Elsie, if you know anything, or
yeah, no, I don't know much about that. It sounds like a bad idea, and I've only read the question in the chat. So, yeah. I mean, I think mining is always a contentious issue, and I think it's something we actually have to think about carefully, which is very relevant to this problem, because as we think about renewable energy technology, then we're talking about a lot of different heavy metals and rare earth elements, and our need for those in battery technologies will shoot up. So we can have, we can decarbonize in some senses, but we're going to be talking about needing some of these elements, and we don't have. So, for example, in the United States, we don't have a lot of active mining because it's politically very unpopular, and it was environmentally somewhat of a disaster in the 1970s, 1980s, when it was really active. And so a lot of that, and I guess this segues nicely to our discussion on China, a lot of that has moved to Asia. And there is a lot of environmental pollution associated with that. So, and we know we can actually do this much better now. So there is technology for clean mining and more thoughtful ways of metal extraction, but with the public, this is a very unpopular issue. So I've kind of shifted the topic a little bit, but I do think this idea of where do we get metals and rare earth elements for the things that are essential uses in our modern society, that's a really important question. And we have to be realistic about it. But we want to do it in a thoughtful way, and we want to use the best technology possible, which we can do. So I'm sorry, I don't know too much about the deep
No.
ocean extraction, but I think it's a super important question in general.
I think I would just add to that, if I can, Elsie, that I mean, and I agree with all of what you said. I think one of the things that is really striking at the moment about our growing understanding of the ocean is that we're beginning to understand that in the deep ocean, life is abundant, whereas previously we'd thought it was, relatively sparse. The number of species we're beginning to understand might be at the bottom of the deep ocean is very considerable. And I think, again, the precautionary principle being, foremost in mind is really the principle that I think many groups and many of those that are concerned about the impact of deep sea mining would really wish to see in place. And I think one of the key suggestions is that there should be a moratorium, at least, on deep sea mining, which could potentially begin in the next year or two. And there's a moratorium in order to be able to let the science really understand the potential scale of and the diversity of life in the deep ocean, as well as the potential impacts of deep sea mining. And I think I would agree, strongly with that moratorium.
Right. When you're dealing with a complex system already at risk, creating more interventions that could be problematic is probably not a smart idea. That's where precaution comes in. So we're hitting time, but I want to ask the last question that was up there. Would a sustainable practices certification, like in the European Union, that the US or EU is about to put in place for emissions related to imported products, be relevant here? So some kind of certification that would indicate that this is a ocean safe product, for example, or a safer product.
It seems like the best question for you, Joel. So thanks for asking it. What do you think?
Obviously, third-party validated certifications are helpful because they help improve the ability of a consumer to recognize this is a better product. It has a lower impact, right? So, for example, US EPA's Safer Choice label is a good, easy way for a consumer to understand this has been vetted through a third party according to a government issued standard. So anything that makes it easier for understanding impact for investors, for example, these types of tools that make it easier to understand that this has a lower impact enhances the marketability. In fact, in our study that Charles showed the graph of, products that were labeled as safer choice, we did a sub-analysis on safer choice. In those product categories, they were growing at 12 times the rate of the incumbent products. So people do want safer, healthier products for their family, for the environment as well. So anyways, any last thoughts? And we'll wrap up at this point. Charles, any last sort of parting thoughts?
Well, no, except to say thank you, Joel, very much indeed for this opportunity. And I look forward to continuing to sort of collaborate with GC3, because I think there's a lot of really interesting work that still has to be uncovered and also explored in terms of particularly the opportunity around green chemistry and the transition that needs to be made. So I really thank you and look forward to potentially future collaboration.
Great. And thank you, Charles, and Elsie as well. Thank you so much for spending your time with us today. For anyone who wants further information, please reach out to us if you'd like to host a future webinar, or if you're not a GC3 member and you want to join us in the future, please reach out to us, and we'd love to have you in this network as we work to tackle some of these large scale but solvable problems. We appreciate all your work, Elsie and Charles, and look forward to working with you as we move forward. So thank you, and thank you to everyone for joining us today, and have a great rest of your day or evening, as it is the case for Charles.
Thank you.
Thank you.